Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 15 of a unit electrostatic potential and capacitance. So let's begin with today's class. In today's class we are going to discuss about the common potential and loss of energy on sharing. So let's begin. This is additional topic and but certain questions, this two sessions, this class and next class will be covered certain additional topics, but that all the topics are very essentials as compared to the competitive examination, so I'm going to cover this. Yes, so first let's understood that what is capacitance of an isolated spherical conductor. We know that in a very initial site that what would be the capacity of an isolated conductor. When we want to find out the capacitance of anything, we just simply do this C is equals to Q by V. So we find out the V. What is the potential of an isolated charge conductor? It's in K Q by R, 1 by 4 pi epsilon naught Q by R. Now if this is V and this has been this charge Q has been divided by V, then what I can have is C is equals to 4 pi epsilon naught R, and 4 pi epsilon naught is in constant, so C is directly proportional to the R. This R is the radius of conductor that you know. Yes, this is radius of a conductor. Now loss of energy on the sharing. Let we have a two capacitors C1 and C2, and this two capacitors have a total charge on them which could be given as Q is equals to Q1 plus Q2. So this according to the Q can be considered as a C1 V1 plus C2 V2. I hope this is clear. Yes, so what is common potential? What I understood is what I'm going to do is that let's suppose this is the first capacitor that has been connected with battery. Let's say this is C1, this is V1. This is the another capacitor and it is going to be connected with the battery. This is C2, this is V2. Now what you are supposed to do is you are going to just disconnect this two after they have been fully charged. I have been disconnected here, I have disconnected it here. Again I am going to disconnect this after this two are the fully charged. Now I'm going to connect this two capacitor in a parallel to each. That means this is the first capacitor and this is the second capacitor. One more thing I want to focus is that this is the positive charge plate, this is the negatively charged plate. Even C2 have a positively charged plate here and negatively charged plate here. So both the capacitors same polarity plates has been connected with each other. If reverse of the polarity has been connected, what happens we will see the next, but please remember that these are the relations and these are the things that can be used when both the positive plates has been connected. So let me revise this. That first this was the situation that battery V1 was there and capacitor C1 was there. Initially C1 may be uncharged, but now after connecting with the V1 it has been charged completely. Same way as second capacitor C2 were there and it has been connected with the battery V2. Now it is going to charge, and once it is fully charged it has been disconnected. Now both these are connected in this fashion. This is C1, this is C2. Now let us suppose that this is C1 is at potential V1, C2 is at potential V2. Now what happens? According to the law of conservation of charge, they are going to share the charges so that their potential would be equal. So what I mean is they came to a common potential, and we are here to find it out that what would be the value of that common potential. I hope those things are clear to you. Is it? So let's begin. Let we are considering that V be the common potential after the charge has been shared, and total charge on the capacitor is after sharing of charge should be equals to q1 dash plus q2 dash, and q1 dash it would be a c1 into v. This v is the common potential. This is common potential. This is common potential. This is q equals to v into c1 plus c2. Now q, initial q was the c1 plus c2 into v is equals to c1 v1 plus c2 v2. This is the initial situation. This is q1 and this is q2. This is the charge on the capacitors before they have been connected with each other. So this v, or I can write it's in vcm for the common potential. It is a c1 v1 plus c2 v2 divided by c1 plus c2. Please write this in your notebook. This is the common potential. VCM is equals to C1 V1 plus C2 V2 divided by C1 plus C2. Yes. Next, what is the potential energies? So let's first find it out that potential energy of the two capacitors before these two are connected with each other. The initial energy were half C1 V1 square plus half C2 V2 square. Now once they have been connected, what is the potential energy after that? Then after that they reach to a common potential, and that I represent as in V. So now the final energy is the final energy of the first capacitor is it is the half into C1 into V square, and the final energy of the second capacitor it is the half into C2 into V square. So in a totality this is half into C1 plus C2 into V square. Now if I want to find out the loss, in the, this is relation number 1. Yes, if I want to find out the loss in the energy, how could I find it out? How could I? Yes, how could I find it out? So let's replace this relation, that this is final energy. U dash is equals to half C1 C2 and V square. I have replaced the value of the V. This is C1 V1 plus C2 V2 divided by C1 plus C2 whole square. And now I'm going to find out the loss of an energy. That loss of an energy would be equals to U initial. It's an initial energy minus of final energy. My initial energy were the half C1 V1 square plus half C2 V2 square. And my final energy would be equals to something like this. It's an half into C1 plus C2 multiplied by V square, and my V is something like this. It's a C1 V1 plus C2 V2 whole square divided by C1 plus C2. So if I solve this completely, what I can have is this is equals to half C1 C2 divided by C1 plus C2 into bracket V1 minus V2 whole square. This is the final result of the loss of energy. I hope these things are clear to you. Is it clear? These things are clear to you. Is it clear to you? Yes? Are you sure? Okay. Now let's move to the second situation. Situation 2. That suppose this is one of the capacitor having capacitance C and is being connected with the battery V1. So this is the positive polarity, this is the negative polarity once it has been charged completely. Yes, this is the another capacitor, capacitance C2, and connected with the another battery, that battery is V2. Now once it has been charged, this would be the positively charged, this would be the negatively charged. Yes, and now I am going to disconnect this two after they have been completely charged, and connecting this two like this. That this is positively charged, this is negatively charged, and this would be negatively charged, this would be the positively charged. I hope this is clear. Is it? Now I need to find out the VCM. So here what we have did is that this was the C1, this was the C2, and both the capacitors have been connected in parallel, but they have been connected with their opposite plates. That means A positively charged plate has been connected with the negatively charged plate, and negatively charged plate has been connected with the positively charged plate. So what can I do? I can write a law of conservation of charge according to the law of conservation of charge. What I can write is that C1 V1 minus, because they have been connected with the opposite polarity, C2 V2 is equals to C1 plus C2 into VCM, and this VCM or the common potential would be given as C1 V1 minus C2 V2 divided by C1 plus C2. I hope these things are clear. Yes. Okay. Now one more thing, I have calculated the loss of energy. Now loss of energy can be calculated as it's a half into C1 C2 divided by C1 plus C2. Here it would be a V1 plus V2 whole square. If you go through the relation in the previous case, it is, if you go through the relation, it is like this. It's in half C1 C2 upon C1 plus C2 into V1 minus V2 whole square, and here it is a V1 plus V2 whole square. I hope those things are clear. Yes, is it clear? So shall I summarize this and go to the questions? Shall I? So let's begin then. Suppose now the situation is, it's a summary, that this is the situation. A first capacitor, battery V1, another capacitor, and battery V2. Yes, let's say initially they were connected something like this. That this is positive plate, this is negative plate, and this is positive plate, this is negative plate. So in this situation their VCM was C1 V1 plus C2 V2 divided by C1 plus C2, and their loss of energy delta U, their loss of energy delta U would be equals to 1 by 2 into C1 C2 divided by C1 plus C2 into V1 minus of V2 whole square. This is the first case, that if battery of same polarity has been connected. Yes. And let's move to the second case, that this is the situation, that this is first capacitor, this is another capacitor, this is C1, this is C2, but here opposite polarity has been connected, this is minus and this has been plus. So in this situation VCM could be calculated as C1 V1 minus C2 V2 divided by C1 plus C2, and this delta U could be considered as half C1 C2 divided by C1 plus C2 into bracket V1 plus V2 whole square. I hope those things are clear to you. Is it clear? Is it clear? So shall we move to the numericals? Shall we? Shall I move? Okay, let's move then, and have your pen and paper and do it with me. Let's say a parallel plate capacitor of capacitance C has been charged to potential V, and now it has been connected to another uncharged capacitor of capacitance 2C. Find out. First, find out first common potential, and second energy lost. So how can you do it? Go through the data very carefully and think that what can you do. Go through the data carefully. What they have given is a PPC is there, and its capacity is C, that has been charged to a potential V, and now it has been connected to uncharged capacitors of capacitance 2C, but here it's an uncharged capacitor, so its voltage would be a 0. This is given. What I require? I required a common potential. So first, one more thing, they have not provided that whether the same plates has been connected or opposite plates has been connected, but it is not required at all, because this V2 equals to 0. I hope this is clear. Yes, as this V2 is equals to 0, so it is not required that they have been connected with the positive plates together or negative plates together, because V2 is 0. So common potential, it's an VCM is equals to C1V1 plus C2V2 divided by C1 plus C2, as V2 is 0. So this is equals to C into V divided by C plus 2C. It's a 3C. This has gone, and this is V by 3. This is VCM. This is VCM. This is V by 3. Yes? Is it clear? Now, this is the first part. Now, what is next? What is next? It's an energy lost. This is energy lost. Delta U, it's an half into C1 C2 divided by C1 plus C2 upon V1 whole square, because V2 is equals to 0. Yes, so this is equals to half into C1, it's a C, C2 it's a 3C divided by C plus 2C, it's a, sorry, it was a 2C. So this is C into 2C divided by 3C multiplied by V square. So this C would be a gone. This 2 would be a gone, and only the term remain is 1 by 3 into C into V square. This is energy lost. Delta U is equals to 1 by 3 CV square. Yes, I hope these things are clear. Yes. Now shall I add something? Yes, so let me add here. Find out charge on each capacitor. I want to find out the charge on each capacitor, so let's try to find it out. What they have given is that this was the capacitance C, and it has been connected with the V. This another capacitance is 2C, and its potential is 0. Now they have been connected with this, it's a C and 2C. We have already calculated the VCM, it's V by 3. So what I understood by this is that I can connect this two capacitor with the help of a battery, and that battery would be a V by 3. So what is the charge? What is the charge of this? Let's say this charge, let's say charge on this, it's a Q1. It's a charge on this, it's a Q2. Yes, so if I write Q1 is equals to C into V, this is equals to C into V by 3. Now let's write out the Q2. This Q2 is equals to C2. This is C1 into V. This is C2 into V. This is 2C multiplied by V by 3. It's a 2CV by 3. I hope this are clear. Yes. So this is Q1 is equals to CV by 3. This is Q2. It's a 2CV by 3. I hope this is clear. Shall I add something more? Shall I add? Shall I? Okay, let's see in the next slide. If I have been asked that question, that in the previous question, find out charge transferred from capacitance C to 2C. You need to find out the charge transferred from capacitance C to 2C. So if you look at this again carefully, initially this is possessing a charge of CV, because this is the value of Q is equals to CV simply. And now after they have been connected, it is having a charge of CV by 3. So Q initial is the C into V. Q final it is a CV by 3. So difference of this, it's a delta Q. Delta Q is the amount of charge that has been transferred. So it's a CV minus of CV by 3, and that would be twice of CV by 3. This is the amount of charge that has been transferred from one capacitor to another. Yes, even you can observe this from here as well, that initially the charge of this is 0 because V is 0. Afterwards it is having a charge of 2 CV by 3. So initially it contains nothing. It is at 0 charge because its potential is 0. And now it is on the 2 CV by 3. So this is the charge that has been donated by capacitance C. Yes. And 2 CV by 3 is the charge received by another capacitor. So again, the total charge of the system remains the conserved. Total charge of the system remains conserved. If you want to calculate this, it's a C into V. This is CV by 3 plus 2 CV by 3. Yes, so the final charge of the system, yes, it's again CV, and the total charge of the system remains the conserved. I hope you understand this whole phenomenon. Is it? So can we do this kind of questions? Can we? Shall we? Okay, let's move then and find out the new question. Suppose one of the capacitor is there. This is of 4 microfarad connected with a battery of 20 volt. Another capacitor is there. It is of 2 microfarad. And this has been charged with the 10 volt. Now this is the situation, that this is the 4 microfarad capacitor. This is its positive plate, this is its negative plate, and this is 2 microfarad capacitor, but this is its negative plate and this is positive plate. Now you are interested in find out first common potential, and second you are interested in energy lost. So you are interested in this two aspect. You need to find out the common potential and you need to find out the energy lost. So first look at this. The both the capacitors have been connected with their opposite polarity to be attached. Yes, so VCM VCM should be C1 V1 minus of C2 V2 divided by C1 plus C2. So my first capacitor was of 4 microfarad and connected with the battery of 20 volt. So this is 24, so it's an 80 minus of. Another is the 2 microfarad and connected with the battery of 10 volt. It's a 20 divided by C1 plus C2. It's a 4 plus 2. It's a 6. Yes. So this is, so if you don't know this, you can have a copy of that. Yes, it's a 4 microfarad at 20 volt and 2 microfarad at 10 volt. Yes. So it's a 80 minus 20, 60 by 6. It's a 10 volt. This is common potential. This is the common potential. Now you want to find out the energy lost. The energy lost would be calculated as delta U is equals to half C1 C2 divided by C1 plus C2 into bracket V1 plus V2 whole square. This is equals to 1 by 2 multiplied by C1. It's a 4 microfarad multiplied by 2 microfarad divided by 4 plus 2. It's a 6 multiplied by V1 plus V2. It's a 20 plus 10. It's a 30 volt whole square. So if I solve this, it's a 4 by 6. That means it's a 2 by 3 multiplied by 30 square. It's a 900. So this is equals to 300. This is 2 into 300. This is 600 joule. This is the amount of energy that has been lost. This is the amount of energy that has been lost. I hope these things are clear. Is it? Is it? I hope these things are clear. Is it done? Is it? What was your answer? What was your answer? Is it same? Is it? Is it same? Are you sure? Great. So ready to move to the next question? Are you? Are you ready to move? Let's have a look what they have given. The question says that a 20 microfarad capacitor is charged to 5 volt and isolated. Okay, it is then connected in parallel with an uncharged 30 farad capacitor. The decrease in the energy of the system will be, even they have provided the hint what the situation is. Let's have a draw it, that a 20 microfarad capacitor is there and it has been connected with a battery of, I think, 5 volt. Yes, it is 5 volt. It has been completely charged and then it has been disconnected. Then one more capacitor is there which is of 30 farad, but it is uncharged. This is 30 microfarad, I think. Okay, it is when this is 20 farad. So this is of 30 farad, but its potential is 0. And now these two are connected. Now these two are connected. I need to find out the rest of the things. How could I do this? Yes. So if I go with the formula only, it's a 20 farad, it's a 30 farad. If I go with the formula, what I can have is that delta U is equals to 1 by 2 multiplied by C1 C2 divided by C1 plus C2 into bracket V1 square, because V2 is 0. Yes. So if I solve this, it is 1 by 2 multiplied by C1. C1 is the 20 farad multiplied by C2, it's a 30 farad divide by 20 plus 30, it's a 50 multiplied by V1. V1 is the 5, it's a 5 square, so it is a 25. So this is 25 2s are 50 and 2 2s are 4, 4 5s are 20. It's 150 joule. This will be the answer. Yes, here it is. Yes, what was your answer? So do you have a same answer? Do you? Do you have a same answer? So will you be able to solve this kind of questions? Will you be? Are you sure? Ready to move next question? Ready? Yes. Let's have a look. What is provided and what is required? What this says is that a parallel plate capacitor of capacitance C is charged and then disconnected from the battery. Okay, and the energy stored in it is E. Now, if a dielectric slab of dielectric constant 6 is inserted between the plates of the capacity, then the energy and capacitance will become. Yes. Do you remember this concept? Do you? It is the concept that we have learned in the last class only. Yes. If not, go through it one more time. One more time to the question. What they say is a parallel plate capacitor is there, and that parallel plate is capacitor of capacitance C is charged and disconnected from the battery. That it has been charged and then disconnected, and the energy stored in it, this energy stored in it is given as the E. Now this is if a dielectric slab of dielectric constant 6 is inserted between the plates of the capacitor, then energy and capacitance will become. Here battery has been disconnected. Yes. So if battery has been disconnected, charge of the capacitor remains the same. Charge of the capacitor remains the same. So what I can write is that my initial charge and final charge would be the equal. So Qi is equals to Qf, and I know that final capacitance, it's a K times of initial capacitance. And what about the energy? What should I write? I should go with the half CV square or Q square by 2C. With which should I go with Q square by 2C or should I go with the half CV square? Yes, you are correct. You should move with the Q square by 2C because charge is the constant, and as charge is constant, let's move with it. That means the final energy is equals to Q square by 2 into C of final. Initial energy would be equals to Q square by 2 into C of initial. This 2 gone, this charge has been gone, and Ci by Cf, it's a 1 by K. That's it. These are the answers. As this is 6 has been given, so they are interested in the energy and the capacitance. So capacitance will be the 6 times and energy would be 1 by K. It's an E by 6. I hope those things are clear to you. Is it clear? Okay. Shall I add something, or shall I let's have a look. That if in previous question dielectric slab has been inserted while battery is still connected, find out new energy and capacitance. Yes, this is new question. that if in the previous question, if previous question were there and dielectric slab were there, if in the previous question dielectric slab has been inserted while battery is still connected, we need to find out, the new energy and the capacitance. So what can I do? What I know is, if battery is connected, if battery is connected, Vi should be equals to Vf. That I know. If battery is connected, then Vi should be is equals to Vf. Final capacitance would be equals to K times of initial capacitance. So here Cf is equals to 6 into C initial. Now what about the energy? Yes, again you need to consider it's an half CV square or it's an Q square by 2C. Yes, definitely for the half CV square. So here UF is to UI should be is equals to CF divided by C, and this CF is equals to K into C divided by C. This CC would be a gone. So this UF is equals to 6 times of U initial. This is it. Yes. So can you do this kind of questions? Can you? Yes, we did it already, this kind of questions in the previous class. Yes, you must remember each and every concept because this all are very important concepts. Yes, so let's move to the next question. What the data has been given, look at this. What they ask is two insulated metallic spheres of 3 microfarad and 5 microfarad. They are charged to a 300 volt and 500 volt. The energy loss when they are connected by a wire. The situation is that this is one of the sphere and this has been capacity of 3 microfarad, and that has been charged with the 300 volt, sorry, and another capacitor is there which is having a capacity of 5 microfarad, and this has been connected with the 500 volt. Now let's say if these two are connected with certain wire, what would be the energy loss? Yes, here I have written the solution for the hint purpose, that energy loss can be calculated as 1 by 2 into C1 into C2 divided by C1 plus C2 into V2 minus V1 whole square. Yes, so if I put up the value, it's a C1 into C2, this is 3 multiplied by 5 divided by 2 into 3 plus 5, it's an 8 multiplied by V2 minus V1. So this is equals to 500 minus of 300 whole square. Yes, but here it's a C1 into C2, 10 to the power minus 6, 10 to the power minus 6. So it's a 10 to the power minus 12, and here only 10 to the power minus 6. So this is 10 to the power minus 6. Yes, I hope you can calculate this and find out the answer. Will you? Can it be done? Are you sure? Okay, great. So let's move to the next question. Let's look what the data is asking from us. What this given is that a body of capacity 4 microfarad, is charged to 80 volt, and another body of capacity 6 microfarad is charged to 30 volt. Okay, when they are connected, the energy lost by 4 microfarad capacitor is, great. How will you do it? What I consider is that this is the situation. That first they have been connected like this. It's a 4 microfarad and 80 volt. Then it is an 6 microfarad. This is the 6 microfarad and 30 volt. Now they have been connected with parallel to each other. So things would something like this. It's a 4 microfarad, and this is of 6 microfarad. They have nothing mentioned, so I assume that this plates are positive positive, even this are the positive, so it is obvious that these are the negatively plates. Yes. So first let me calculate VCM. What is it? It's a C1 V1 plus C2 V2 divide by C1 plus C2. So that can be that can be 4 multiplied by 80 plus it's a 6 multiplied by 30 divide by 4 plus 6, it's a 10. So this is 4 8s are 320 plus 63s are, it's a 180 divide by 10. So this is 320 plus 180, it's a 500 by 10, it's a 50 volt. Now initial energy of a capacitor UI, it's a half into C1 into V1 square. So this is equals to 1 by 2 into 4 microfarad into 10 to the power minus 6 into V1 square. Their potential, its potential is 80, so it's a 80 square. And so this is, if it is 2 into 10 to the power minus of 6 into 80 square, it's a 6400. And the final energy of capacitor, it's a half into C1 into, now it is on the common potential, so it's a VCM square. So this is equals to 1 by 2 multiplied by, it's a 4 into 10 to the power minus 6 multiplied by, it's a 2500. So let's say this is 25200 into 2, it's a 5000 into 10 to the power minus 6 joule. Yes, the difference of the UF and U initial is the change in energy. And if you want to find out the lost, then calculate UI minus of UF. I hope those things are clear to you. Is it? So can you solve this? Kind of stuff? Yes. Are you sure? Great. So let's wind it up here. But before I turn off, I request you to go through this unit, because this is very longer unit. As you know, this is already the lecture number 14, or this is probably the 15th lecture. One more lecture is to go, and in this we are again going to discuss certain additional topics that have been asked in the competitive examinations. Yes, and then we will go through our series, that is of previous year asked questions. But I request you to genuinely go through all the topics, because these are the basics. These are the basics of the electrostates. Yes, we are going to complete this, and we are going to switch to the current electricity. So this two are units. First unit is the electric charge and field, and this second, electrostatic potential and capacitance. This two will make an electrostate for us, and at least 3 to 4 questions in both kind of examinations, while I talk both kind of, in the JE as well as in the NEET or in the medical examinations, has been asked. So please go through it very carefully. This is required. Please practice a lot. This will save us. Yes, thank you. Have a good day. Take care.